When you balance chemical equations, drawing particles can help you keep track of whether you've got the right number of atoms on each side. So for instance, we've got Na plus O2 giving us Na2O. Let's draw a sodium atom and an oxygen molecule. On the right hand side we've got Na2O. So 2 sodiums and 1 oxygen. Na2O is actually not made of individual molecules, but this is a good way to visualize it. So you can see there's 2 problems here. We've got 2 sodiums on the right and only 1 on the left, and we've got 1 oxygen on the right and 2 on the left. So we can fix either one of those. First, I'm going to fix up the oxygens first, so I'm going to draw another Na2O on the right hand side. And that fixes up the oxygens, but now it increases the sodiums on the right hand side to 4. So I need to draw another 3 sodiums on the left hand side. So now we can just literally count the atoms. On the left hand side I've got 4 sodiums. On the right hand side I've got 4 sodiums. On the left hand side I've got 2 oxygen atoms, and on the right hand side I've got my 2 oxygen atoms. So that equation is balanced. All we need to do now is write in the coefficients. It will be a 4 in front of Na and nothing in front of O2, which implies a 1, and a 2 in front of Na2O, and that equation is balanced. Let's look at a more complex example. So we have ammonia, which is NH3. We have that reacting with oxygen to make NO2 and H2O. Let me move this molecule across a little bit. Alright, so we can see some problems here. We've got 3 hydrogens on the left, but only 2 on the right. I've got 1 nitrogen on the left and 1 on the right. They're good. Oxygens on the left, I've got 2, and on the right, I've got 3. When you're dealing with an individual element and the rest are compounds, like in this case, and in combustion reactions, do that individual element last. So we're going to do oxygen last. So let's fix up our hydrogens. I need more hydrogens on the right hand side, so I'm going to draw another water molecule in to try and increase my hydrogens. So my hydrogen atoms have been increased to 4, which is now more hydrogens on the right than the left. So I need to increase them on the left hand side. So balancing equations is always going to be a trial and error process, no matter what strategy you are using. So now I've got 6 hydrogens on the left. Let me draw another water molecule on the right. Blue for oxygen. If you are drawing them, keeping them different colors helps you just to identify them. So 6 hydrogens on the left, 6 on the right. They are balanced. 2 nitrogens on the left, but only 1 on the right. So let me add another nitrogen. I can't just put a nitrogen on its own though. Nitrogen comes bonded with oxygen. So we fixed up our nitrogens, 2 on the left, 2 on the right. Let's go to our oxygens. On the right hand side I've got 1, 2, 3, 4, 5, 6, 7 oxygens. On the left hand side I've only got 2. Oxygen is diatomic, so no matter what number I put as a coefficient on the left hand side, when I multiply it by 2 it's always going to give me an even number. So if I want 7 oxygens on the left hand side, a number I could use is 3.5. So let me draw in 3.5 molecules. So there I've got my 3.5 molecules of oxygen. At this point what you could do is you could double everything to make our oxygens a whole number. I'm obviously not going to draw that because the numbers are going to be too big to draw, but the particle diagrams can give us a start and show us where the problems are. So this equation, to balance it, in front of NH3 I'm actually going to have a 4 instead of the 2 molecules you see there. Instead of 3.5 oxygens, I'm going to have 7. I'm going to have 4 NO2s, and I'm going to have 6 H2Os. Let's have a look and see if that works out for us. So nitrogen's on the left hand side, I've got 4, and on the right hand side I've got 4. Hydrogens, I've got 4 times 3, which is 12. Hydrogens, I've got 6 times 2, which is 12. So nitrogens are good, hydrogens are good. Oxygen, I've got 7 times 2, 14 on the left. On the right hand side I've got 4 times 2, 8. But I've also got some oxygens here. I've got oxygens in 2 places. I've got 6. So the 6 and the 8 gives me the 14, which is the same as the oxygens on the left-hand side. So drawing particles can help, but there are limitations, especially when you get to very large numbers.